Okay. So, I have to admit I am old school OCF. My account dates back to 1991. I don't know if it's still active or not. There should hopefully be an email forward if it isn't. Many of you know me. I mostly have been teaching in the computer science department, but I've been doing other things too. So this is talking about my outside work that hasn't succeeded yet, but it's been lots of fun. So let's talk about drones. Drones are super damn cool these days. And the reason why we have these proliferation of these small drones is two really unique technologies. First of all, the batteries. The batteries are so much better these days than they were just 10 years ago. So the lithium-ion battery technology has been driven by the cell phones and the laptops, and now they power cars. And so the energy density on these things is huge. And so that's allowed these things to fly for a long time. The other thing is what are known as micro-electromechanical systems. So these are small gyroscopes and accelerometers and pressure sensors and the like that are all on little chips, sort of the like 2-millimeter chips, and cheap, so like $10. And this allows you to build inertial measurement units so that you know where you are and how you're moving, because that's what's actually needed to keep those quadcopters in the air. I had some quadcopter toys when they first started coming out without the MEMS, and you could not fly them. Basically, you give them a little too little power and they drop to the floor, a little too much power, they shoot up to the ceiling. The revolution on the quadcopters was the MEMS getting cheap enough so that the computer can go, I want to hover. They're also flipping terrifying. That's the other reason I'm interested in these, is I'm a security person. I'm practically paranoid, and these things scare the bleep out of me. This little thing is from Turkey. This front piece here, that is effectively a claymore mine, aka a bit of explosives designed to kill everybody in a football field-sized area. This is an ISIS drone where they took a cheap DJI quadcopter and modified it into a bomber to drop grenades on people. This is footage from a Mexican drug cartel. Drug cartel wars are now air wars. Drug cartels will literally drop bombs on each other from drones. This is a fun one from Ukraine. You can't really see it, but this one has about 10 grenades on it. And we've even seen, actually it's been 5 years now since flying robot assassins targeting world leaders became a thing. It did not succeed, but Maduro was almost assassinated by a couple of DJI drones that somebody bought in Florida and strapped explosive to. And the thing is we need drones to stop drones. So like right now, we have this lovely little thing that the Russians have bought from the Iranians to use against Ukraine. This is basically a moped-powered cruise missile. It's a 50 horsepower, 500 cc engine, costs someone between $10,000 and $20,000. This is too cheap to shoot down with a missile. If you shoot down this thing with a surface-to-air missile, congratulations, that hit its target. Its target was the surface-to-air missile. And the thing is currently that thing can be kind of shot down because it's under basically autopilot. It just goes in a straight direction. the next generation of attacking drones are not going to be manually guided or just follow a set. They'll just have the cameras and decide what to do automatically, because that's how you deal with jamming. That currently, radio links are the weak point in the drones. You jam the drone, it stops being able to communicate to the operator and basically can't do anything anymore. But autonomy is how you get around it. You build the drone so it looks around, goes, okay, I can't talk to anybody, kill all humans, and it goes on its own. And I want to build drones to fight these drones, as well as do other things. And that's because you cannot beat a computer's reflexes with a human. This dates back to my early security work with very high-speed internet worms, was showing that these worms were so fast that humans cannot mitigate them. The drones are the same thing. If we want to deal with drones, we need automatic systems to deal with drones, and so I want to build drones to fight drones. To put it in another parlance, yo dog, I heard you like slaughterbots, so I'm building slaughterbots to slaughter your slaughterbots. So about me. As an academic, I'm a computer security, but I'm also a computer architecture person. My dissertation was actually on PhDs, or I mean on FPGAs. My PhD dissertation even includes the chapter I like to call Why This Dissertation Was a Fucking Stupid Idea. It took a few hundred pages of work written down behind years of work to understand why it was a stupid idea, but nevertheless. So for research-wise, my primary home is at ICSI. I've had in the past a huge focus on building real-world systems that actually work. So we built like the Nettalyzer system that was used like 1 million times for comprehensive network testing over the years. I'm part of the team that killed the Viagra spammers. Nothing feels better like putting a $100 million a year Russian criminal enterprise out of business. Okay, there is something that feels better. It's being in the middle on the author list, so if the Russians ever had decided to start shooting, I have meat shields on either side. And I do a lot of public policy writing, so like I believe that cryptocurrency needs to die. But that's a subject for a different rant. And then teaching, I largely focused on computer architecture as well as computer security. But as a lecturer, I don't have a formal sabbatical, but I really burned out hard a year ago. That the fall, I co-taught 61C and co-taught 161, and in the spring, I co-taught 61C and solo taught 161. And I had to fight to get the university to even consider that an 80% time position. They wanted to call that a 60% time job. Being responsible for 1% of all Berkeley undergraduate education. You can understand why the burnout hit. So I needed to take a break. So basically this academic year, I started my own business. My focus is building low-cost, human-safe, fully autonomous drones. I've yet to see a profit, but there's good stuff for classes. So if I ever teach against someplace else, like if Stanford, say, hires me to teach, I have plenty of fodder. So in looking at drones, there's several observations that are really important. First is, autonomy buys a huge amount when you're talking drones. Seeing your environment and making decisions. Because this allows you to work where you don't have communication. It allows removing operator skill. Being a certified, FAA certified drone pilot is easy. Actually being a skilled drone pilot is very, very hard. I am proof that one does not equal the other. I'm good at crashing them. Autonomy allows you to remove operator skill. And that means you only need certified operators, not skilled operators. And there's a lot of interesting applications when you do have autonomy. The problem is the current autonomous drones are just too expensive. They're trying to do autonomy correctly. And by correctly, I mean high reliability, high capability. So like the Skydio drones, the industrial drones they sell are $10,000. They have 6 HD cameras with fisheye lenses arranged so any point in space is viewed by 2 cameras, a high-end NVIDIA embedded processor, and they cost a fortune. They're really cool, but I can't afford that.
You use Alibaba better.
I prefer Banggood myself, but we'll get to that. The other thing, though, is the hobby field is where it's at. So, like, the military field, this is a small drone designed to deliver a baseball-sized payload to somebody you don't like. It costs $10,000. That's considered low cost by military standards. Nice DJI prosumer Mavic 3. They're optimized for endurance, ease of use. They're $1,000 for the airframe. They're good, as long as you don't mind shipping all your data to the Chinese government. They're brilliant. I love them. I have one. And then you have the hobby drones. And I love the hobby drones because they're designed for people like me. They're designed to be crashed. They're designed to be cheap. And so, like, it becomes a very different economic structure when you're trying to leverage off the hobby market. And all 3 markets are very separate. That the hobby stuff doesn't tend to overlap with the DJI stuff all that much. DJI is trying to get into the hobby space with their camera setups and the like, but they're just way too expensive. What are you going to do? Are you going to spend $300 on the DJI Air unit for the video transmitter, or get the $30 off of Banggood or Alibaba? Another thing is human safety matters. There's now, in the past couple of years, been a definition of human safety. And the FAA has 4 categories. Category 1 is no laceration hazard. That is, if the drone smacks up against you, it shouldn't cut you, which basically eliminates most quadcopters without a blade guard anyway, and less than 250 grams. Category 2 is no laceration hazard and a low kinetic energy impact damage. It's about getting hit by me throwing a baseball. Category 3 is no laceration hazard and moderate impact damage, like somebody who can actually throwing a baseball. And then category 4 is a formal FAA airworthiness certificate, aka the same paperwork you need to do to make a plane that you can sell for people. Category 1 is easy, but you can't do much with. Category 4 is very, very, very pricey. Category 2 and 3 are where it's at. Give up on quadcopters for category 2 and 3. You take a 1 kilogram quadcopter, bring it up 1,000 feet, turn off all the motors, it will kill somebody it hits. You take a fixed wing that weighs weighs a kilogram, drop the motor, it's going to glide down, and when it hits, it's all basically bumper foam, and so it won't kill somebody. So fixed wings are where it's at, if you want safety.
But if you, this might be different, but like if this drone was meant to stop another drone, or to, like, I guess, stop another drone from blowing something else up, wouldn't it not fall under any of these categories? Because
it depends. I want to do multiple applications. Some applications, like taking drones out of the sky, you aren't worried about human safety. Other things, you really are. So if you want to, say, get an FAA waiver to fly a drone out where you can't see it in real time, with an operator with eyes on the drone at all times, I would not try to get a waiver for that without being able to say, this is FAA Category 2. Remove 9s from reliability, remove 0s from the cost. This is a great lesson from computers. Solving 99.999% reliability is very, 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 very hard. Expensive computers, stuff like that. If you haven't figured it out by now, I'm lazy. I'm so lazy, I'm recycling this talk. 99% is much easier. If I don't need to solve the complete problem, my problems become so much easier. After all, how much better is your code productivity writing-wise if you don't have to pass all the test cases? But in order to do this, I need to make crashing okay. I need to be... Crashing is always an option. If I crash, so what? The only way I can do that is basically making my designs both super inexpensive and human safe. Because I want it to be, if my drone screws up and hits you, you are pissed. Because it's not my drone screws up and hits you, it's my drone screws up and hits me. And frankly, I want to be pissed if my drone hits me, not dead. So I care about human safety, personal reasons. Number 5, the Raspberry Pi is one of the most impressive inventions in the past 10 years. Because it's no longer a toy. The current Raspberry Pi 4 is about 100x better to 1000x better than the workstation I had in 1991 when I was going to Berkeley. That was the top of the line Unix workstation at the time. It was a Next Station. And I used it for all the Berkeley undergrad CS curriculum. And most of the classes could run on it just fine these days. The Raspberry Pi is so much more. And it has a really nice camera ecology too. So the Raspberry Pi has this 2-lane CSI camera interface that has good software support. So you can get StarViz cameras that can work at like a quarter moon or less ambient light. You can get 64 megapixel cameras. You aren't going to get 64 megapixels of data going through the interface very fast. But what you can do is basically take that camera, that big high-res camera, and treat it as a big low-res camera or a narrow high-res camera. And so this gets you what's known as digital pan, tilt, zoom. So you can look at the whole area, focus in, look at the whole area. Beautiful camera ecology. They're also really optimized for industrial use these days. How many are annoyed that you can't buy one right now? The reason you can't buy one is they're making millions of them right now. They're just all going into devices you don't think about. Because they don't just make the Raspberry Pi that, they also make this version. So this version here is the compute module. This is a Raspberry Pi 4 with the I/O chopped off, replaced by a high-density connector. Basically, this allows anybody who wants it a 5 to 10-year-old desktop computer with massive software support, a huge open source ecology that you can just plug into your product. Oh, and it's already certified on the wireless, so you use a certified antenna, and now you don't even have to worry about FCC regulations on certifying the thing. It's already certified. Basically, the reason you can't buy a Raspberry Pi 4 is this is the same chip, and every one of those there's so much industrial demand because you just don't see it. They have like 1,000 industrial partners at this point.
Also, DRAM prices are ridiculous.
What?
Also, DRAM prices are ridiculous right now.
Yeah, but it's not the DRAM because they're only using one chip. The availability issue is just their Broadcom silicon is all going into the industrial chain. In fact, I'm surprised there isn't a service out now which takes things apart, finds things that use the Raspberry Pi compute module, and tells you what they are, because it's probably cheaper to buy one of those and take it apart than it is to buy from the skeleton. There's also a huge amount of other open source stuff you can steal when you're building stuff. We have OpenCV. It runs reasonably well on the Raspberry Pi. Nice computer vision. It takes 2 hours to compile from source, but we have open source software for video links. We've got multiple open source autopilots. ArduPilot's very nice, but a pain to debug. Beta flight's lightweight, stripped down, optimized for quadcopters. Please tell me I don't need to write my own autopilot. I want to, I shouldn't. But what could you do with autonomous drone? Well, here's a good photo of one of our campus Falcons. I live in Napa. Napa, nothing to do but eat and drink. On the other hand, there's nothing to do but eat and drink. But Napa has a lot of vineyards. And vineyards and other ag have a problem. Pest birds, European starlings, as well as other birds. And these are so much of a pest that there's not one, but 2 companies in the North Bay alone that provide falconers with trained falcons to chase off these pest birds. Yes, there's 2 rental agencies to rent a falcon. The problem is this doesn't scale very well. Falconers don't scale, and net production of Lindsay over here is about 2 falcons to maturity a year. So that isn't a very scalable solution. But an autonomous fixed-wing drone looks like a falcon, can fly like a falcon. The birds will treat it like a falcon. In fact, somebody in Sweden or Norway created one that was specifically designed to mimic a peregrine, and they flew it around over manual control and actually were able to herd a murmuration of starlings around. Another thing is, we're in California. How many love wildfire season? Hey, break out the N95s. I had them before they were cool. If you have autonomy and you have human-safe platforms, you should hopefully be able to get a non-line of sight waiver from the FAA. And when a fire cam operator sees something like this, or more likely a smaller whiff of smoke, it would be really nice to be able to send a drone over that ridge, over that ridge, over that ridge, look around, come back. You're going to need a line of sight waiver, and I don't see the FAA saying you can do that cheaply unless you're human safe. But also, when you can do this, well, you dispatch, fly around, look back. Autonomy is necessary because, well, your cell phone really doesn't work well when you're behind one of those ridges for some reason. I don't know why. If it's human safe, it won't hurt somebody. Low cost. If it crashes, who cares? If it sees that there's a manned aircraft in the area by receiving the radio signals, it goes, okay, I don't want to be here. Fall down, crash. Who cares? It's cheap. And finally, I want to stop drones. This is my real goal, because the future battlefield is going to be filled with these bloody things. How do you stop an autonomous drone? Build a drone-killing drone. You just have to make it autonomous or you're out of luck. So one of the things you can do is take a fixed wing, have it be basically dragging ribbons, cables, fish hooks, whatever. If you fly that over a hostile drone, and when I mean over, I mean like this far over, that hostile drone's not going to be flying anymore. Because if it's a quadcopter, it's going to suck in those things into its propellers and they're going to stop working. If it's a fixed wing, it's going to get hit by that flying fish hook and ripped apart. And, well, if that doesn't work, just turn around and ram it. If your drone's only $800, who cares? So let's put this all together to start making autonomous drones. So my compute module. This gives me the ability to do processing images and decision cycle at a reasonable rate. This allows me to do all my non-hard real-time stuff on a nice full Linux environment. One of the first things you realize whenever you want to do something with real-time is don't. Basically, take a second processor and shove everything real-time onto that. Cheap components, off-the-shelf hobby motors, chassis, etc. Make a custom autopilot. This is my custom autopilot. I designed myself. I had made up. It mates your Raspberry Pi compute module to 2 cameras. Let me click it back in and I'll hand it around. So it mates it to a GPS, IMU, camera interfaces, an AI accelerator that doesn't work because of PCI bus incompatibility, power supply, servos, pass it around. And then 3D printing. 3D printing is so fun. Bamboo Carbon X1, just got one. Ooh! So I want to do this for 2 things, business and classroom. That I would love to build a class where we turn this into a class. So the students are given components to build completely, like build a low-level autopilot. So design the hardware for the board, have the board assembled, make the software for the board for an autopilot. And then for other stuff, larger completed blocks, so like you give them the autopilot hardware with the larger integrated software. And then at the final, you have an autonomous race against the faculty member. I love competition classes. I hate competition classes. I love them because for a lot of students, competition is really fun. But I hate it because a competition-centric class faces the students off against each other. And that's bad. So I believe that any competition-centric class should be player versus environment. The faculty is the boss monster. You don't have to beat your fellow students. You have to beat the professor. And this also has the advantage of, as being the benchmark in the environment, I can nerf myself if I decide I'm too good. And if I'm not good enough, well, oh my God, my students are so smart. I had to give them all A's. What a shame. How will I ever recover? Oh, now I've recovered. And so overall, I believe that player versus environment is a better way to structure classes. So how do you go about doing this? Well, first step is board design. Board design is fun. So a circuit board is basically digital baklava. You've got layers of insulator, layers of conductor that make a 2D arrangement of wires, and then holes drilled between them to carry current between, or carry signals between. So you have a signal that can go anywhere from layer 2 to 7. You can have a signal that can go from anywhere 1 to 8, a signal that can go from 8 to 7, 7 to 6. Circuit board design is fun. So you need to design on a set of what's known as design rules and stack up. So the design rule says how close things are, how far apart they are, and the stack up says how many layers, what via types you can have between them, etc., etc. And there's some real interesting nonlinearities. Going from 2 layers to 4 layers is actually cheap because you have a lot of fixed costs. Going 4 layers to 6 layers to 8 layers, that really starts to add up. You can go up to 16 or 20 layers if you want, if you're feeling truly psychotic and have somebody else's money at stake. I would not advise that myself. There's other things that you can do, like what's known as via in pad. So like these vias are drilled holes through, And so if you put a device on top, it would suck the solder down the hole and you wouldn't get a good connection. But you can do what's known as via in pad, and so that hole gets filled up, and that way you can do things more dense. My advice, if you're willing to go with Chinese production houses to get the boards, 4-layer 4mm design rules with 8mm vias and via in pad is really nice. You can do good power supplies, good power distribution, deal with these fine pitch VGA packages and everything else, and not break the bank. Another thing you need to do is select a CAD tool. If you're cheap, there's KCAD and EagleCAD. They're free. Well, KCAD is free, EagleCAD costs money. If you have some money, you go with Altium Designer. If any of you want to design a circuit board, you're still students. Buy Altium Designer. The cost for students is 0.0 for a year license. For commercial use, it's $4,000 a seat year. I'm paying for it. It's worth it. Because Amdahl's law applies to all sorts of things. So it costs you a fair bit to make your first main. Why not pay for the real software? Also, Altium has real nice ties to supply chain, so you can actually go do a design, get the thing of, can I actually buy the parts that make up this design? And it will go to DigiKey and all the others and put them all together and say, this one you can't. Okay, I'm going to redesign now rather than before I got the board. Another thing to decide on is components. That basically circuit board design is like Lego. You lock down things together, wire them up. Most components don't have direct substitutes. A lot of things have only a single vendor, so you actually want to do a lot of your part selection before you do any other designing. Some parts are widely available. Some things are scarcer. There's this service called Octoparts, which is great. You sign up for it. It will automatically notify you when that hard-to-buy item came into stock. And as an aside, ST Microsystems and Texas Instruments are the two companies right now taking the global economy. STM32, H743, VIHWs are still not available in any decent quantity. Trust me, that's on my Octopart notification. So a microcontroller is a small computer with a lot of specialized I/O and some non-volatile storage. ST Microsystems makes the most popular ones. I actually don't think they're the best. My revised design, I'm still going with the ST to run Autopilot, but I'm also throwing a ESP32S3 on it because it's dual core with floating point, and dual core makes my life easy.
The point on this S3 isn't that good, though.
I don't care about it being that good. What I care about is that it's dual core.
Makes sense.
Because dual core means that for an autopilot, I have to, if I end up having to write an autopilot, I do the real-time loop on one core and everything else on the other, and don't have to deal with all the real-time OS crap.
Have you seen like the new core they announced though?
Which ones?
They announced like the C6.
Sorry, the S3. The C6 doesn't have what I wanted. It's the S3 that I'm using, the one with the Wi-Fi built in. Dual core and Wi-Fi. Because, hey, I love abusing networking protocols. TI's even worse. So one of the things that, if you ever building hardware, you quickly learn about is the pain of voltages. My lithium-ion battery comes in somewhere between 7 to 36 volts. My compute module is nice and only needs a 5-volt power supply. My microcontrollers all need a 3.3 volts power supply. And if I'm unlucky, I have something that requires a 1.8 volt power supply or a 1.1 volt power supply. And there's two ways to do this. You can do low voltage regulators, which are inefficient. That basically a voltage regulator dropping from 5 volts to 3 volts, that 2 voltage drop times whatever current is going through is how much power that voltage regulator is going to put out. Which is all fine when you're going, say, from 5 volt to 3.3 and only like 50 milliamps. It ain't so good when you're going from a lithium-ion battery to 5 volts and you want to be able to pump out 4 amps in order to be able to drive servos. So for that, they make these things called buck converters or buck modules. So how those things work is you have a chip that is basically flipping open and closed a switch at really high speed, outputting that through an inductor, then to a capacitor as a LC circuit, and then measuring with a feedback loop to measure the voltage. And TI makes the best. It's not like ST. The TI buck modules are so great because they are this big, include the inductor, so it saves half the board space over the alternatives, and they have 1-year lead times. I've got my precious stock of about 200 of these things, although I've got the 63604s, which are a different chip, but will work for me. I've stockpiled 200 of them because whenever a couple came on sale, I'd go and buy them. Because if I wanted to buy these $12 parts from a scalper, I'd have to pay $140 each. TI! And even if there's an alternative, you're going to have to redesign things. These are the companies tanking your global economy. So now you do the hardware design. You make up your board. This is the nice glamour shot of my board.
That we just
What?
that we passed around.
Yeah, that passed around, although this is a slightly different revision. You send it off to be manufactured. At sort of my level of complexity, getting 5 boards is $4,000. Getting 100 boards is $10,000. There's these huge non-recoverable engineering costs in doing prototypes. How do you do it? Well, if you're cheap, they're really good Chinese assembly houses. You don't want to use those for drones, though, because you want to sell to the US government, and the US government says no Chinese controllers in their drones. If you can speak your credit card number, there's plenty of US houses, but they charge a fortune. I've used Sierra circuits multiple times. They're good. And then 2 weeks later, you get your boards. You can speed things up if you're willing to pay more, and you get your boards in your hand. And so this is the board that I passed around. Actually, no, it is the exact rev. I just never populated that because I couldn't find that frigging connector. That one connector was out of stock, so therefore it's not populated on that board. Now you start to assemble airframes. This is the fun part. This is shopping time. So this is my test quad. It flew just fine until I burnt out a motor, crashing it. As I said, I'm good at crashing. This is one of my test fixed wings. Again, this one just crashing. I haven't had good luck with fixed wings yet because I'm incompetent. And then play with 3D printers for custom components. So like this roll cage is something I 3D printed because the first time I flew this thing, I didn't have the roll cage and it landed upside down when I crashed it. And this is where I'm pretty much in the flow right now because I'm developing software. So I need to modify the low-level autopilot. Assuming I don't rewrite it if I find somebody else. I need to build a vision processing pipeline. So I've already shown that I can get the cameras working and all that. Students last spring were able to get 8 frames per second with OpenCV, so I know I can get fast enough for what I need. And they didn't take advantage of caching. and that's a application that caches wonderfully if you do it right. And I need to resist the urge to write my own autopilot. Must resist urge. I'm a believer in old school machine vision. So 2 frames separated in space can give you stereo. So this is live shot from my backyard, taken from the drone. 50 frames later, it's a good shot of the grass. And not moving. Because I crashed. But it's nice and easy. 2 frames separated in time, you can do what's known as optical flow, where you go, I'm here, then I'm here. Cheat, move straight forward, it's easy, but you can do it fancier. And you can use this to do both collision avoidance, identify things of interest. So like, for so many of my applications, I want to see, is this a valid target? I don't want to do, is this a valid target on my whole scene? I only want to do, is this a valid target on something that's up in space flying around? That's what the 3D reconstruction gets me. Because I don't trust AI. I just don't. I'm a security person. And it's not that it's going to go Skynet on me, it's that it's going to go DERPnet on me. And so use digital pan tilt zoom for high resolution. So go with a model where I have my attention wide and narrow depending on mode. And only when I have AI things for actual target identification. Because I don't trust AI. And finally, the profit. Okay, I have the underpants gnome profit model. If you don't know about the underpants gnome business model, you gotta look it up before you go into business. I'm at phase 1. I owe a 4 on SBIRs. I've gotten a little money for consulting gigs. So I'm currently in the midst of a pivot on my business model. So I think I'm wearing my politics on my shirt with regards to the Ukraine conflict. So I'm doing a revision of my board right now where I'm adding in a low bandwidth data link that I'll use for a bi-directional data link to the drone that's designed to be not the most jam resistant in the world, but reasonably jam resistant because you can hop around within the frequency range very easily on a packet by packet basis. And critically, on the back channel, you tell where the drone is, and there you aim high gain, highly directional antennas using an antenna tracker. I think I can get a 30-kilometer range out of this with a video link that would be reasonably jam resistant. Because the other thing is I can play games on my drone receiver and have multiple antennas that are very directional as well. Because there's a target I want to take out. I want to take out this thing. I want to take out this thing. Currently, the best way Ukraine has been able to take this out is they've got these German tanks, well, not tanks, but anti-aircraft guns. Flakpanzer, literally anti-aircraft shooting tank. And the thing is one of those can only kill one of these things if it gets within about a couple kilometers. I think this toy should be fast enough. That is a sub $300 race drone chassis that can hit 200 miles an hour in a dive. Outperforms Lindsay the Falcon. Even has a nice little hole underneath where I can make a nice little rig to have a nice big fish hook on it and a nice little bundle of steel cable. And you fly over that thing dragging a number 1/6 fish hook that's this big from Amazon, attached to a steel cable, and if it engages, that thing ain't flying anymore. And if it doesn't, you just turn around and ram it because, hey, $300 drone, $800 total, who cares? The other thing that I've done is I have started the fabrication process so I can design, or so I can fabricate my boards in-house. Well, assemble them in-house. Because I'm sick of paying $4,000 whenever I want a revised version of this. So I've got my 3D printer, I've got a benchtop reflow oven, I've got a pick and place machine, which is an automated robot that takes all these little pieces and puts them on. You then put it in the oven. 2 prototype runs will pay for all my equipment. We have entered a revolution in the ability to do in-house board assembly that's really new, and it's only been in the past couple of years. The Neodin YY1 is really nice if you're looking for slightly lower precision. The Opulo Lumen open source one is available, and there's actually one in the which is the Cori makerspace. Yeah, Supernode has a Lumen YY1 now, or I mean, sorry, a Lumen PNP, a Lumen V3 PNP machine, because I initially got the Lumen, decided it didn't have enough precision for me, and got the YY1. So I gave it to them. Long-term profit, you don't sell drones, you sell drone services. A skilled drone pilot costs way more money than the drone itself. Getting the FAA license for commercial operation is easy. I dare say I give everybody in this room the training manual 2 hours and have you take the test, and 90% will pass it. It's not hard. Gaining the skills to not repeatedly crash, especially on the fixed wings, is hard. Quadcopters are easy. You just hover them. Fixed wings are hard because you can't just let your hands off the control and it just stops. So you sell services where you charge as a skilled pilot but don't need one. So you hire certified pilots and you charge like it's skilled pilots. So the bird abatement, you charge 20% less than the falconers do. Maybe 30% less. But you can also handle way more customers. The long-range surveillance, you're getting the FAA waivers so the customer doesn't have to, and then doing a network operation model. So whatever you want to do surveillance on, be it the border, fire, or a big ranch, or whatever, we provide you the infrastructure. You just put these drones out, we've done all the paperwork. And so I take that $1,000 drone and I lease it to you for $300 a month because I'm doing all the service for it. I like that idea. Counter drone to the US, well, then I'm building it like the hobby style, but I'm gonna sell it at that military price because, dude, you're willing to spend how much for this? Mistakes, I've done a lot of them. So I was in a hurry to get incorporated. I incorporated myself in California. Mistake. If you ever want to incorporate a business as a full C corporation, incorporate in Delaware. It costs a little bit more, but the corporate laws are so much better that if I end up taking outside money, the first thing that it's going to pay for is the lawyer to spend twice as much as it would have cost in the first place to reincorporate in Delaware. Just period, full stop. Lots of design bugs. I've got fun ones. Antennas backwards. The first version I made, the switch was dead for the US. Lots of bugs. Lots of bugs. Lots of magic smoke has gotten released. I've made 5 of these. This version, I got 5 boards back. I still have 2 that are considered working. 3 are dead due to various electrical incidences. Rapid, unexpected disassembly of the magic smoke particles that make the things run. Supply chain issues. I think you've already figured out what my thoughts on TI and ST are right now. And finally, this may be too big on my own. I really need a team because I'm not the best in the world. I really want somebody else to be CEO. Almost makes the idea of going the venture route worth it, just have some other fool manage the business crud. Basically, I have 3 job titles: CEO, janitor, really bad janitorial service, and chief mad scientist. The chief mad scientist is the part I like. But it's been fun so far. So I haven't had the profit yet, but this has been really fun. But this is also scary. There's a reason my company name is Skerry Technologies. These things scare the hell out of me. This is 2 steps up from hobbyist level, is what it is taking to think about building autonomous drones now. We're also in an age of miracles. You can design real hardware, build integrated systems. You can build stuff like this yourself. You've got 3D printers. You've got really nice outsourced services for cutting and the like, so that my previous prototype quad, I had a custom cut frame instead of abusing a race drone chassis. I basically made a design, sent it off in email, arrived 3 days later. And it's remarkable what you can insource now, that you can now insource circuit board assembly for a total budget. My total budget that I'm spending on my circuit board assembly pipeline is less than $8,000. $1,300 for a reflow oven, $1,300 for a good 3D printer, because 3D printers are the ultimate tool for building tools and jigs and holders and feeders and everything else. $4,000 for a pick and place machine, and I've come to the conclusion my stencil application skill is bad enough. I'm going to spend $1,000 and get a professional stencil frame rather than the tape together 3D printed jobby I'm currently using. What? I initially had an Ultimaker 3. I got it very early on, basically about 6 months after Jacobs Hall got theirs, because they were clearly robust enough because it stood up to student abuse. I still have that, but that was bought with my soft research money at the time. I now have a Bamboo Carbon X1. That has really impressed me. It's so fast. It's like 3 times faster than those Ultimakers. The multi-material handling is not the best in the world because it basically poops, but it's fine for the purpose of easy to change materials. So I've got black PLA, gold PLA, blue PLA, green PETG, and I'm going to replace one of the random PLAs with nylon carbon to do structural parts. And I've been very impressed with that. I'm not sure how well it would stand up to say student duty. So I think the Ultimaker line is better for the Jacobs Hall model, where you've got basically running 24/7 students. But for an individual shop printer, I am so impressed with it. Among other things, the material handler includes desiccant packs built in, so it's a dry box.
Does the printer actually print like the nylon carbon well? Or, like,
I don't know. I just ordered the nylon carbon last night. So I'll be able to tell you on Friday when I go into my shop and do a couple of test prints with nylon carbon. And then the nylon carbon, I will, the one I got, they recommend annealing at 80°C for a few hours, but that's what the reflow oven is for, because it's a really nice, well temperature controlled reflow oven, so I can just set it to 80°C and bake and let it bake for a few hours. So, any other questions before I hold you all from the pizza?
Wait, so how long has it been since you started?
So I started this seriously at the start of last summer, but it's still only a part-time gig. So I'm 40% time through ICSI on a existing project that, among other things, A, gets me some money, and B, pays for my health insurance. I've done a couple of side projects that have distracted me. So like that paper on cryptocurrency, that came with a $5,000 honorarium, so I spent a fair amount of time on that. And I've got another contract for doing a report now. But I hope I'm almost done with the circuit design, and the layout tends to be very straightforward for me because ripping it up and redoing it many times gets you very quick at it. So in the next couple of weeks, I should have a revised version of my board sent to circuit board assembly or circuit board manufacturing. I'll get the bare boards back and assemble in-house. And I'm setting up that design so I can do partial assembly too. So like coding things, so I can say I only want to assemble the power supply. So I'm going to not assemble the entire board at once. I'm going to just assemble a test with the power supply, then more and more and more. Both to save components, because I have only 200 of those buck converters. I only have 30 odd of the STM32s that I want to use. But other things I can get cheaply. So like the ESP I can get super cheap and get a bunch of those. So I'm going to do partial assembly, make sure that things work, and iteratively test each subsystem by only assembling that subsystem, putting it in the oven, toasting it, and getting it out.
And like, yeah, what is your plan like with the company? Because it is like more of a part-time thing right now, but it seems like you're really passionate about this too.
So over the summer, it's going to be 60% time. I actually, because I got some contract money coming in for writing about blockchain naming services. But since that counts as business income, I can go with things countervailing for business expenses. So I'm going to hire a couple of students over the summer, part-time. I wish I had more time to work on the radio link stuff, because I wish I had it working already. But basically, as soon as I've got a prototype working, I have some contacts in Ukraine, and they're going to be getting one hooked into a Strix goblet going, please just see if you can catch those things. And if you like it, figure out how the US can spend money and I'll get you a lot more.
Yeah, that's pretty cool.
Likewise, I have a DARPA proposal that I'm working on, which is basically translated to give me $500,000 and I can defeat the US Army. Basically, how can you cheaply achieve air dominance below 50 feet?
such as a proposal, would you be able to expound on how to defeat the US Army under 50 feet?
Small, cheap, large numbers, fully autonomous. So you sweep opposing drones out of the sky by just overwhelming numbers because you're so cheap. And you go for not necessarily full swarming tactics, but a lot of ambush tactics. Because one of the things is if you're flying at treetop level or below treetop level, you're really hard to detect. And you basically cannot be detected until literally the last second. And if you have a projectile or explosive form projectile or something like that that has even moderate range, basically whoever sees first shoots first. And you just have a lot of cheap eyes.
Would you ever use it against the US government?
No.
I see.
Oh, I'm kind of fascinated by all this stuff. The stuff you're talking about reminds me of, I think, Professor Stuart Russell's talk on like
Yes, the
AI
slaughter bots.
Slaughter bots. What is your thought on that stuff? Do you think that AI-driven drones and weapons are going to become popular and they're going to become a huge problem in the long term?
Stuart Russell and I have a fundamental disagreement on this. He believes that you can ban this stuff. My belief is that autonomy on these systems is inevitable just simply to handle the communication problem and the reflex problem. You cannot build human-in-the-loop systems and beat a computer. The best you can do is human-on-the-loop system. That is, the human gives high-level guidance, but any detailed decision is computer done. And you have to have full autonomy for when communication fails, because even a human on-the-loop system requires communication. So the systems are going to be autonomous. There's just so much engineering necessity for that. The other thing is that the problem I've had with the folks who seek to ban autonomous weapons is it's actually really hard to say what's too autonomous. So if you look at, say, a landmine, is a landmine an autonomous weapon? Yes or no? What about these smart sensor-fused landmines that will only detonate on something big like a tank? Because you actually have these smart landmines that will have their integrated sensor see a vehicle cross, see that the vehicle matches it's not a Hilux category, but actually looks like a tank, and only then detonate. Is that an autonomous weapon? Would that be a forbidden autonomous weapon? That's the thing, is that I don't think bans are possible. I think instead we're looking at a really nasty arms race, and if you want to win an arms race, you need a head start. Especially because it's one of those arms races that doesn't rely on the huge industrial base anymore. It relies on the smaller industrial base and creativity. And like, I have a slide deck for the DC types, which is, if I was a small nation, how could I spend $100 million a year on defense infrastructure and make it so that the US would not win an invasion? I don't mean defeat the US. I just mean accelerate the process so that instead of taking 20 years to lose, to admit that the victory was Pyrrhic, they admit it within 20 days. And the cheap autonomy favors that model. And this is something that really worries me long term. And in fact, like, from a security standpoint, I'm surprised President Biden is allowed to ever walk out in the open air. It really stuns me because these things are so crazy. But I don't believe that the policy intervention of banning is going to work. So I'm not interested in that. I'm interested in building systems that can take out these things first.
I'm pretty sure EMPs are illegal, but have you considered like really cheap drones that can like emit like an electromagnetic pulse to just disable like any drones nearby without?
EMPs are weird. First of all, it's actually hard to get enough energy out short of an explosive. So I've seen designs for collapse an inductor explosively to generate a huge current pulse to drive a microwave emitter type thing. I don't know if those even work. But the other thing is tinfoil. That you don't need to completely eliminate the EMP, but just dropping it by 2 orders of magnitude in terms of energy is going to render it useless anyway. And big EMPs take nukes.
I'm just curious, like, if you see like an increasingly accelerating arms race on the drone scale that eventually obsoletes like human infantry or whatever, do you ever see like the I guess the scale of like war returning to like just a purely digital avenue instead? Because even just fighting with drones seems to be roughly kind of useless.
No, because what you do is you use the drones to target the other side's leadership. So you have, say, a narco sub full of 10,000 drones off the Atlantic coast and lob those all at the Pentagon at once. That autonomy, you use autonomy to fight autonomy, but the autonomy is also used to attack people. And attack logistics and stuff like that. So, unfortunately, I don't see that happening.